All right, guys, today's lesson we are going to be looking at limits at infinity. Okay, so we're going to be evaluating some limits as x goes to either infinity or as x goes to negative infinity. Now, there is an algebraic way to do this, and that's given to you in this hint right here. Divide the numerator and the denominator by the highest power of x in the denominator. Okay, and that works great, but it's a lot of work, and these really don't require a lot of work. Almost all of these are, you can look at it and say what the answer is with very minimal work. Right? There are a few weird ones that we will have to do a little bit of work for, but most of them are look at it, say what the answer is. So I'm going to do one problem where I show you this method so you know what it is and you've seen it before. This is kind of what you do if you really can't figure out what the answer is, do this method. Okay, so for letter A, the highest power of x in the denominator is x to the first power. So this says we're going to divide everything by x. So I'm going to rewrite my limit as x approaches infinity. And I have 3x divided by x minus 1 divided by x divided by 2x divided by x plus 5 divided by x. All right, and then we can simplify this a bit. So the limit as x approaches infinity, the x's cancel right here. So I get 3 minus 1 over x. And the x's cancel right here, so I get 2 plus 5 over x. And so if we let x go to infinity, then the denominator of this fraction gets really, really big. It's huge. And so if you have a constant on top and you're dividing by a number that's getting bigger and bigger and bigger, that fraction is going to 0. And so same thing with this one. Constant on top, the denominator keeps getting bigger and bigger and bigger, so that fraction is going to go to 0. So we end up with just 3 minus 0 over 2 plus 0, which is equal to 3 halves. All right, now what I want you to notice about that answer is if we go back to the original problem, that's simply the coefficients, dividing the coefficients in front of those x's. Okay, so hopefully that kind of makes you think about something. Right? We've done something before where we divided the coefficients to get an answer. Okay, that something was horizontal asymptotes. That's what limits at infinity are. They are horizontal asymptotes. Okay, you've heard a word before called end behavior. That's what we're finding here. The word end refers to infinity. That's what's happening at the end. Negative infinity is the left end, positive infinity is the right end. Okay, so in rational functions, which is most of what you have to deal with limits at infinity, the end behavior is a horizontal asymptote of some sort. All right, so we are going to follow our horizontal asymptote rules. So we don't have to do this process every time. All right, it works the same way. You can always do that process, but we don't need to. What we can do is identify this as one of the 3 types. So remember, you have top heavy, you have bottom heavy, and you have balanced. So we're going to identify each problem as top heavy, bottom heavy, or balanced, and then we can just say what the answer is from there. Okay, so this is the exact same function as the one above it. Okay, this one is balanced because x to the first power over x to the first power. Okay, so you don't have to write balance, but I'm going to write it for our notes right here. So this is balanced, and when it's balanced, it doesn't matter if we're going to positive infinity or negative infinity in this case. Okay, sometimes that will matter. We'll see a couple examples where it does. Okay, but in this one, it doesn't matter because the horizontal asymptote is the same thing on both the left side of the graph and the right side of the graph. It's 3 over 2. Okay, you're never allowed to do this, by the way. This was a big talking point on the AP exam last year where kids did this. So they had the limit as x approaches negative infinity. And then they wrote their work like this. They did 3 times negative infinity minus 1 over 2 times negative infinity plus 5. And so they know that infinity dominates. So we can ignore these parts. And then it's a negative divided by a negative. So it was equal to, not that, undo. All right, it's a negative divided by a negative, and the infinities kind of cancel out, if you will, and then 3 over 2. is the answer. Okay, that is bad. All right, you are not going to get, you're going to lose credit on the AP exam for doing that. You are not going to earn any points. They do not want to see you plug infinity in for x. Infinity is not a number. So the only things you can plug in for variables are numbers. So they never want to see you plug an infinity in. So that's why we just identify it by its type, and then we know we divide the coefficients, and that's our answer. All right, next one's top heavy. Top heavy is always equal to either infinity or negative infinity. So we just have to figure out which infinity it is. Well, positive, if x is going to positive infinity, then this function on top goes to positive infinity, and this function on bottom goes to positive infinity. So it's a positive divided by a positive, which is a positive infinity. Okay, if x goes to negative infinity, then x squared still goes to positive infinity because it's squared, but x will go to negative infinity. So it's a positive divided by a negative, so this will be a negative infinity. Okay, just to do a little extra on that one. So if I were to show work on this, I would not do the whole divide by x thing. Right? That's what you're doing. But here's a quick way. I'm just rewriting the problem. So anytime that you're doing a limit where x goes to infinity, any terms that are smaller than your greatest degree term in the top and the greatest degree term in the bottom, you can ignore those because the highest power term is going to dominate the rest of the function when x is really big. So we can ignore that. We can ignore that. So if we ignore those, then we just have this, and we can just simplify that, right? So that's equal to the limit as x approaches infinity of 3x over 2. And now that's a function you should be able to just draw a quick graph. Okay, it's got a y-intercept of 0 and a positive slope like that. And so as x goes to positive infinity, the right side, our graph is going to positive infinity. As x goes to negative infinity, the left side, our graph goes to negative infinity. And there's your two answers there. So that's a quick way to show some work to verify that your answers are what they are. All right, next one. All right, these two are bottom heavy. Bottom heavy is always equal to 0. Doesn't matter if it's positive going to positive infinity or negative infinity. Your answer is going to be 0 if it's bottom heavy. Okay, I'll show you the divide by x method on this one as well, just to like, why is it equal to 0, you may be wondering. So if we divide by the highest power in the denominator, we get the limit as x approaches infinity of 3x over x squared minus 1 over x squared divided by 2x squared over x squared plus 5 over x squared. Okay, and so this 1 over x squared is going to go to 0 because denominator gets big, the numerator stays the same. Okay, this one, you can simplify a bit. 3, the x cancels here with the squared, but you still have 3 divided by x. X gets really, really big, numerator stays the same, so that cancels out. So I have a 0 on top. Down here, 5 over x squared, that's going to be 0 as x gets really big. And then here, the x squareds cancel, and you're left with 2, so you end up with a 2 on bottom, 2 plus 0, which is equal to 0. So anytime it's bottom heavy, the numerator will always end up equaling 0. Your denominator will be some number of some sort. It won't be 0 as well, because then that'd be indeterminate form. And if you have a 0 on top and a number on bottom, you get 0. That happens with bottom heavy functions every time. All right, next one. These are the tricky ones right here. Okay, so top heavy, bottom heavy are balanced. Okay, so if I'm looking at it, I'm thinking, all right, well, if I square root x squared, I get x, and I have an x on top. So these are balanced. So I'm going to divide the coefficients. Okay, we're going to show a little more work on this one. Okay, so when I'm doing a limit as x goes to infinity, I can ignore any number that is smaller than my highest power. So I'm just going to cross out the 4. I don't need to worry about that. Okay, then I'm going to rewrite this. The limit as x approaches infinity, we have our 2x on top, and then the square root of 9 is 3, so I'm just going to put 3. then the square root of x squared. So everyone's going to want to write just x, but it's not. Okay, think about it. So square root of x squared. Okay, let's say I said, what is the square root of 1 squared? That's equal to 1. Okay, could I produce another value that's also equal to 1? Okay, and hopefully you see, yes. If I put a negative 1 and I squared it, I would get positive 1. Then I square root it, I would get positive 1. So there's two possible answers. If you have the square root of x squared, it could be a 1, it could be a negative 1, and that'll give you the same y value. So anytime you're dealing with like a positive, negative version of something, that's an absolute value. So just write this in your notes. The square root of x squared equals the absolute value of x, not just x by itself. Okay, now that's a big deal because the absolute value of x, piecewise definition, is equal to x when x is greater than or equal to 0, and it's equal to negative x when x is less than 0. Okay, so that's a big deal because when x is going to positive infinity, x will be greater than 0, so we can replace our absolute value of x with an x. 2x over 3x. Okay, and then you can either think of this as being balanced, so you're going to divide the coefficients, or you can think of it as the x's cancel, and then you have a constant left over, 2/3. That's the answer. How does it change over here? All right, so a lot of the same first steps. We don't care about the 4. We can rewrite this as the limit as x approaches negative infinity of 2x over 3, absolute value of x. And then we can rewrite that as the limit as x approaches negative infinity of 2x over 3 times, but since we're going to negative infinity this time, we're now on the bottom part of our piecewise. That's x is less than 0. So we have to replace that with a negative x. And so the x's still cancel, but you get negative 3, 2 over negative 3. And so it's negative 2/3 instead of positive. Okay, those are the toughest ones. If you can understand those, you're pretty much good to go. We'll have a couple on the back that are a little tricky as well that we'll talk through. But in general, you're looking top heavy, bottom heavy, balanced. Top heavy means you get infinity or negative infinity. Bottom heavy means you get 0. And balanced means you divide the coefficients. And that's how you do these problems. Almost all of them, you just have to look at it and then go through your categories. Not a whole lot of work to show. Occasionally you get strange ones like this. All right, let's talk about this one, then we'll move on to the back. So the x squared gets really, really big. The sine graph, think about the sine graph. It doesn't get really, really big. It just keeps doing the same thing over and over and over. It oscillates. Okay, so that's very similar to just remaining constant, right? If this was just a 2 on top, that could be like y equals 2 right there. The sine graph is very similar. It's going above and below, but the center of the sine graph is staying the same. So when we're thinking about is this top heavy, bottom heavy, or balanced, this is bottom heavy. The top is staying the same. The bottom's getting bigger. Bottom heavy. Bottom heavy functions are equal to 0 when you do a limit as x goes to infinity. All right, on to the back. Okay, this is a bunch of stuff about even and odd functions, which I've covered in other classes, other lessons, I mean. So I'm going to skip over that for now, and I'm going to go to this page. Okay, so this is from another curriculum. I wanted to do some other problems that deal with limits at infinity. These have some other interesting kind of problems that we can see. So the first 3 are kind of standard, just like what we just saw. So I would encourage y'all to try these on your own. And then you can come back and unpause the video and see if you got them right. All right, so if you had a chance to try these on your own, I'm not going to spend a ton of time here. This is balanced. 4 divided by 8 is a half. This is bottom heavy, so it's 0. This is top heavy. I'm going to positive infinity, so it's going to go to positive infinity as well. All right. This is talking about the divide by the highest power of x. Okay, it's also talking about bottom heavy powers equal top heavy in here as well. Okay, so let's see what we've got here. These are some more. This one, All the ones on the top, again, I would encourage you to try on your own first, and then come back. All right, so if you had a chance to try this one, hopefully you got 0, bottom heavy. This is 4/5. Be careful on the ones with a bunch of terms. They sometimes like to mix the terms up and like put your highest power over here just to like throw you off. They didn't do that on this problem, but just watch out for that. This one's top heavy. It's going to infinity, so infinity. All right, this one's kind of a tricky one. This one's a little bit new. So is it top heavy, bottom heavy, or balanced? Okay, so well, hopefully you know that the square root is a 1/2 power. So this is x to the 1/2. This is x to the 1. 1 is bigger than 1/2. This is bottom heavy. So that means this is equal to 0. All right, then these two are like the ones we just did. We can ignore the terms that are not the biggest power. That square root of x squared is going to be an absolute value of x, which if we're going to positive infinity like we are in this first problem, we can replace with an x, which means our answer is 1/2. Over here, since we're going to negative infinity, we have to replace it with a negative x. So it's negative 1/2. All right, I think I have a couple more. Yes. Okay, so these are the more interesting ones. So top heavy, bottom heavy, or balanced. Okay, e to the x grows really, really fast. X grows, they both go to infinity, but the bottom is going faster, much faster than the top is. So this is considered bottom heavy, which means our answer is 0. I'd have a supplementary question to this one. Okay, what if I gave you this limit? So the limit as x approaches infinity of x to the 1/1,000,000th power divided by e to the x. Top heavy, bottom heavy, or balanced. So they're both going to go to infinity. Okay, they're both going to go to infinity pretty quickly. Right, 1,000,000th power. Just think about 2 to the 1,000,000th. Right, that's a huge number. Right, that's way bigger than e squared. Okay, but an exponential function will always overpower a power function in the end. So eventually the exponent down here will be bigger than 1,000,000, and it'll start multiplying faster and faster and faster. So it doesn't matter what the power is. An exponential function is always more powerful, which makes this bottom heavy, which means this is equal to 0. This one, the limit as x goes to infinity, it's balanced. Exponential on top, exponential on bottom. Those are the same. So this is balanced. We divide the coefficients, and we get 1. Big change, though, if you go to negative infinity. So this is another supplementary question you can write yourself. The limit as x goes to negative infinity, the same function, e to the x plus 4 over e to the x minus 4. So if I were to plug in negative numbers for x, okay, so I don't want to plug in negative infinity. I'm not allowed to do that. But if I just plug in like negative 100, okay, then that's we can rewrite this as the limit. So I'm gonna change this to the limit as x goes to infinity, positive infinity, and I'm gonna put that negative in the exponent there, e to the negative x. So instead of having my negative in the values that we plug in, I'm just putting the negative here, and then we'll plug in positive numbers for x, and that'll make them, the negative up there will make them become negative. Okay, and so we can rewrite that as 1 over e to the x plus 4. And same thing down here. And then this little fraction right here is bottom heavy, because the e to the x is on the bottom. So when x goes to infinity, that fraction goes to 0. This one, okay, it's fine. I thought I read it wrong. But this fraction is also bottom heavy. As x goes to infinity, the bottom gets really big. That fraction goes to 0. These are constants, so they just stay the same. And so the answer is 4 divided by negative 4. which is -1. So definitely watch out for those. Those are the trickiest ones in my opinion. The e to the x's where you go to negative infinity. You have to remember that the exponent part, the exponential function, is going to cancel out in that scenario, and you'll be left with any constants that might be in your function. All right, and then we already talked about this one on our notes. The top is going to stay the same. It oscillates, but it stays the same basically. The denominator gets really big. This is bottom heavy, which is equal to 0. All right, hope you enjoyed that lesson. If you have any questions, let me know, and I'll see you for the next one.